Assalamualaikum and good day. We are from course MAT183 Calculus 1. The title of our presentation is Techniques of Differentiation. This video is prepared by Afiq Hadi bin Muhammad Faizal, Muhammad Amirul Rashid bin Muhammad Zaki, and Alif Ashraf bin Nur Jimmy from program CS110 and course group 2C. The topic that we are going to present today is techniques of differentiation. Differentiation is a fundamental concept in calculus that is used to find the rate of change of a function with respect to a variable. In other words, differentiation helps us to determine how fast one quantity changes compared to another. In calculus, there are several techniques of differentiation that make the process easier, especially when dealing with complex functions. Some common techniques of differentiation include the power of rule, product rule, the coefficient rule, and chain rule. In this presentation, we will focus on explaining these techniques briefly and show how to apply them in solving a problem.
So this is a technique of differentiation. First one, we have a power of root power rule. So the power rule is used to differentiate a variable raised to a constant power. To apply this rule, you bring the exponent m to the front to multiply it by the variable and then decrease the power or the original power by 1. The second one is product rule. Product rule is applied when differentiating the product of two functions, which is fs and gs. The rule states that the derivative is equal to the first function multiplied by the derivative of the second function plus the derivative of the first function multiplied by the second function. Now we have a tree rule, which is quotient rule. The quotient rule is used when differentiating a function that is divided by another function. The derivative is found by taking the bottom functions times the derivative of the top function minus the top function times the derivative of the bottom function, all divided by the squares of the bottom function. The fourth one, we have a derivative of exponential function. So this rule is used to find the derivative of a general exponential function where a constant base a is raised to the power of a function fs. The process involves the three parts: rewriting the original one and multiply by the natural log of the base, and finally multiplying by the derivative of the exponent. So we will start the question with a power rule. So first one is multiply the exponent of 5 with a coefficient 6 to get a 30, and then you need to decrease the power of s by 1, and then we get a 30 as power of 4. And for the second term, since s is the power of 1, its derivative is simply 1. And 1 should multiply this by the coefficients, and then it will give a negative 4. For the constant term, the derivative of any constant will be 0, and we combine, we got this. So for the second question is with the product rule. So first, recognize that the equation is y equal to s3 x power of 3 sine x consists of two separate functions, so it must be a product rule. So first, let the first function be fx is equals to x power of 3. So the derivative is a 3x power of 2. The second one is let the first function be the gx equals to sine x. The derivative is a cos x. So we apply to the formula, it will be like this. So fx multiplied by the derivative of gx cos x plus with a derivative fs, wait, fs, 3s power of 2 multiply by the gs sin s. So we will get the s3 cos s plus 3s power of 2 sin s. So the third question is a quotient rule. So we let the top function will be fs 2x power of 2 negative 1. So the derivative is 4x. So the bottom function is a gs is s power of 2 plus 2. The derivative is a 2s. So we apply to the rule, to the formula. So we get wait, let me do it. Plus 2 multiplied by 4x minus 2x power of 2 minus 1 multiply 2x over x 2 plus 2 power of 2. So first ones, we expand the first one. So we will get the equation 4x power of 3 plus 8x, and then we expand these ones, so we get a 4x power of 3 minus 2x over x power of 2 plus 2 power of 2. So the minus will expand, so the 4x is now 0 because 4 minus 4. So 8x will be 10x. X power of 2 plus 2 power of 2. So this is the answer. Okay, for the fourth question is the derivative of exponential. So the first step is we keep the exponential term exactly as is it, which is e3x plus 1. So the next, find the derivative of 3x plus 1. It will be simply 3 because s is power of 1 divided multiplied by the 3. So we got 3. So the answer is 3 e power of 3x plus 1. Thank you.
Thank you to my friend about the presentation before. In conclusion, technique of differentiation help us to simplify the process of finding the derivative of different types of functions. By using the correct technique, such as the power rule, product rule, quotient rule, or chain rule, complex differentiation problem can be solved systematically and accurately. Understanding this technique is essential in solving real-life problems related to rate of change. Only this conclusion that I can give for you. So, the reference used in this presentation are from lecturer note, textbook, and online educational research related to calculus and differentiation.